Hello guys, we are now starting section 6.6, which is the isosceles trapezoid and the kite. But before we begin, I wanted to start with a little joke here, lighten the humor a bit. And I also wanted to talk about how we should go about this process of having the classroom flipped. So firstly, you should watch the videos as many times as you want. So if you didn't get a concept, you can rewatch the video. Secondly, I want you to please take notes. You should be not only including the word notes, but the actual mathematical computations in your notes, so you have examples to work from. So you can also pause during the video. So if you're working on a math problem and you want to see how to do it, why don't you pause it, try it, play it, and see how I did it. So this is interactive. It's not just you watching the video for however long it takes, but it's an opportunity for you to learn with the video. So, sorry for the bell again. Let's begin the next section. So our next section is going to be about trapezoids and kites. We explored them a little bit, and now we're just going to kind of use the properties we discovered. The properties of a trapezoid is a quadrilateral, four-sided figure with exactly one pair of parallel sides. So here you can see we have one pair of parallel sides. The parallel sides are called the bases, and the non-parallel sides here are called the legs. In an isosceles trapezoid, our legs are congruent. So if you look down to the section here, we have an isosceles triangle because we have parallel sides and our legs are also congruent. So this makes it an isosceles trapezoid. When you know it's an isosceles trapezoid, you know a couple things. If it's a trapezoid and it's an isosceles trapezoid, then each pair of base angles is congruent. So that means to me that G is congruent to H and F is congruent to J. Okay, so that's how we've got our congruency involved. We also have, if a trapezoid has one pair of congruent base angles, then it's an isosceles triangle. So if you look at the second one here, we know that the relationship between consecutive angles is that they would be supplementary. So here we would have to have these be congruent. If we have one set of base angles congruent, then we have to have the other set of base angles congruent as well, making it an isosceles trapezoid. And finally, I apologize, it's a little truncated, but if a trapezoid is an isosceles, a trapezoid is an isosceles if and only if its diagonals are congruent. So you're going to have congruent diagonals in these, and within the congruent diagonals, you'll have congruent segments. So if I have point P here, I would have PR is congruent to PQ, and then I could also have PS is going to be congruent to, and I can't see the point underneath the recorder, but P and the point on the bottom left. So not only are our diagonals congruent, but we have sections within the diagonals that are congruent as well. So how does this, now we get to talk about kites. Just kidding, we're going to speak about the mid-segment of a trapezoid. So the mid-segment, if I have a trapezoid, and it doesn't necessarily have to be an isosceles trapezoid, but if I have a mid-segment, so it's drawn through the center of the trapezoid, and so it's parallel to the two bases, it can create congruent segments on either side for the legs. Additionally, what I know is the mid-segment theorem is that basically the mid-segment of a trapezoid is parallel to each base, so parallel, and its measure is 1/2 the sum of the lengths of the bases. What that means is if I add the segment AF to the segment CD and average that, so divide it by 2, that'll give me the length of BE. So we'll put that into practice shortly. Let's finish going over our shapes. The last thing we need to look at is properties of a kite. A kite is a quadrilateral with exactly two pairs of consecutive congruent sides. So these are consecutive and congruent, and the other pair here is consecutive and congruent. So that's what it means by two pairs of consecutive congruent sides. Unlike the parallelogram, the opposite sides of a kite are not congruent and they're not parallel. So this is really a different animal for us. Sorry about the bell again. So the theorems for the kite. If a quadrilateral is a kite, then its diagonals are perpendicular. So I have A to C is a diagonal and B to D is a diagonal. It connects the vertices, and it creates that right angle right there. Okay, again, think Pythagorean theorem when you see that right angle. And then if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. So where the segments are not congruent is going to be where the angles are congruent. Okay, so it's the included angle between the two non-congruent sides. Those are going to be the congruent angles. So let's use some algebra and apply what we've learned to these properties. Okay, so find each measure. We're finding measure of angle D, so we're finding this here. When I look at this shape, I know that it's a trapezoid, and it's not, well, I can look and say that it's an isosceles trapezoid because it has two congruent legs in addition to the two parallel sides, or the two parallel bases. So we can use the properties for an isosceles trapezoid. So that being said, I know that the base angles are going to be congruent. So if angle C is 101, then I know that the measure of angle D will also be 101 degrees because the base angles are congruent. Next. Okay, so now we have, it looks like, another isosceles trapezoid. I have parallel bases and congruent legs. So I know I'm going to follow the properties of an isosceles trapezoid. If W, we're finding WT, so I want to know what WT equals. If X to Z, or ZX, is 20, and T to Y is 15, then I want to find the measure of W to T. Well, I know the diagonals are congruent, so if the entire diagonal is 20, and the larger portion is 15, then it looks like I have 20 minus 15 equals 5. 5 units would be left for the measure W to T. So 5 would be remaining for that segment. Okay, in the figure at the right or below it, WZ is the mid-segment. So WZ here is my mid-segment of this trapezoid. Determine the value of X. So I want to know what X equals. Okay, so the mid-segment is just an average of the two bases. I know that 14 is a base and X is a base, and I need to average those. I know that the average of those bases will equal 8. So let's set up the equation. 14.8 plus X divided by 2 equals 8. 14.8 plus X equals 16. Minus 14.8 minus 14.8. So X equals 1.2. 1.2. And if you wanted to do a check step, you could easily do that. If X here is equal to 1.2, I would want to prove that 8 is the average of the two bases. So 14.8 plus 1.2 divided by 2. 16 divided by 2 is 8, and it works. There you go. Okay, finally we have coordinate geometry. We're not doing proofs in these sections, so we're really not going to spend time doing proofs on any of the specific shapes that we're learning, aside from the parallelograms, which we had begun the chapter with. With these coordinate proofs, you have to draw them out. So I put together if I had graph paper, I'd use it, but I don't, so I can't. So I would assume -4, -1 would be right here, so I'm going to label A, -4, comma, -1. B is going to be -2 and 3, so B, -2, comma, 3. C is going to be, it looks like I have for C 3 and 3, so it looks like it would be, horizontal to it. I'm sorry, I couldn't figure out the word. C 3, comma, 3. And then my D is 5 and -1, which coincidentally, if you look at this Y, it looks like we're going to have something going on that we should recognize. So D is going to be 5, comma, -1. So now I'm going to connect my points, and it looks like I have a trapezoid. Assume it's there. Okay. Again, you're going to have graph paper, so you can draw it to scale. So in order to prove it's a trapezoid, we know a trapezoid has two parallel bases. So when I look at this, I need to be able to prove that BC is parallel to AD in order to say whether or not it's a trapezoid. It's not asking me to say if it's an isosceles trapezoid, so I just need to prove the slope of those two lines is the same. So plugging it into the slope formula, I'm going to work on BC, and the slope is going to be 3 minus 3 over negative 2 minus 3, which gives me 0 over negative 5, so the slope is 0. And for A to D, it's going to be negative 1 minus negative 1 over negative 4 minus 5, change, 0 over negative 9, or 0. So I have proven that it's a trapezoid. I've proven that these segments are parallel, and that's what we need for a trapezoid. So the answer is yes. This is a trapezoid. A trapezoid, because the bases are parallel. You would never know that I'm using a stylus. Parallel. Okay, so this is these are our last shapes in this section. So we're going to be reviewing on the block, reviewing on Friday, and getting ready for our Unit 6 assessment on Monday. I will see you soon.